Okay, so we'll start with our first example. This is cost per unit as mentioned in the table, and the three destination are destination 1, destination 2, and destination 3, and the factory capacity is the next column. So from city 1 to destination it takes $5. From city 1 to destination 2 it takes $4, and city 1 to destination 3 it takes $3, and the capacity of this factory is 100 units. Second is city 2. From city 2 to destination 1 it takes $8. From city 2 to destination 2 it takes $4, and from city 2 to destination 3 it takes $3, and the capacity is 300 units. And from city 3 to destination 1 it takes $9. From city 3 to destination 2 it takes $7, and from city 3 to destination 3 it takes $6, and the factory capacity is again 300 units. And the warehouse requirements as mentioned in the table are 300 units, 200 units, and 200 units respectively. So this is the sheet given to us, and based on this sheet we need to find the minimization of transportation costs while meeting the demand at each destination. So now this becomes a case of transportation problem. So how to solve it? The most easiest method is that I'll take this table again, copy it, go to the other cells and paste it. Okay, and we will change cost per unit to the quantity that has to be supplied. We will remove factory capacity column here. We will cut it, just leave one row, one column blank here. And similarly for the warehouse requirements, we will take this row, cut it, and paste it in the next row. So this we are doing the transportation calculation. So where everything is set, we have to remove these dollar values from city to destination. Now the first part here, factory capacity, this is also known as supply. So always this is known as supply, and warehouse requirements on the row side is always known as demand. So what we need to do here is that we need to find the minimization of transportation cost while meeting the demand at each destination. Okay. So first is that once everything is set, we'll go to this column to sum, and sum of city 1 to destination 1, 2, and 3, and close the bracket and drag it down. Similarly for the demand side, we'll take the sum of first destination for all cities, sum it and drag it down. is the minimization cost. Now here we have to use the function sum product of the cost, comma, and how much demand is to be there. So now this becomes a column of demand. Close it. Initially it will be 0. Just select the cell, go to data, press it. On the extreme right hand side you will find solver. Press it. Okay, so don't change anything here because we have already selected the cell 2. Now here we have to find minimization, so I'll select here min. By changing cell variables, I want to find how much demand has to be met. So I will select all of these cells, subject to constraint. This value should be less than or equal to 100, and second value less than or equal to 300, and third value less than or equal to 300, and 0 should be equal to 300, and this 0 should be equal to 200, and this 0 should be equal to 200. Okay, so all 6 constraints are set. Don't change anything here, and we need to change Yaji non-linear to simplex LP method, and that's it. So we find a solution. So the minimum cost of transportation will be 4,000, and the demands are met. So destination 1 from city 1, all 300 supplies are made. From city 1 to destination, so all the demands are met. And similarly, from city 1 to destination, I will supply 100. I will not supply anything to destination 2 and 3. From city 2, I will supply to destination 2 200 quantities and 100 quantities for destination 3. Similarly, from city 3 to destination 1, I will supply 200 units. I will not supply anything to destination 2. I will supply 100 quantity to destination 3. That's it for now.